Okay, so we're going to just review this. Keep in mind, if it's a circle, it's a female. And these are pedigrees, right, just to help you get through. Hopefully this will help with your homework. When males and females are connected by the hip, it represents marriage. And their offspring are connected by their heads. And if we had one or any individual that is filled in, that means that they have the recessive phenotype. And so by default, these two individuals have the dominant phenotype. Okay, so let's just practice a little bit with this one down here. So what we notice is that to be albino is recessive. To have normal pigmented skin is dominant. So the individuals are the easiest to identify are the individuals with the recessive phenotype, because the only genotype they can have is homozygous recessive. And next we can go through and figure out the ones that are a little bit more difficult. So in order for these two individuals to have at least one child that is homozygous recessive, each of these individuals need to have a little a to give. And because they're not filled in, we know that they have the dominant phenotype, which means that they must have a capital A. In the same sense, in order for these two individuals to have children that have two little a's, this man can only give a lowercase, right, a recessive allele. But his wife must also be able to give a lowercase, a recessive allele, in order to be able to have children that are. These individuals are the next easier ones to do because all of them have to be heterozygous. And that is because their father can't give them a capital letter. So there's no way that they can be homozygous dominant. Okay? As we come back up here, we know that one of them must be heterozygous because that's the only way that they can give this child a little letter. So I'm just going to pick the mom, and the dad we don't know. So the dad can be either one. And the same with these other individuals. We don't know about them. So we'll write them both because we don't know for sure. All right, so let's move on to the next page and we'll do this practice. So this one is talking about lung disease. I'm going to make it just a little bit bigger. This one is talking about lung disease here. So we know that this individual is, that lung disease is recessive, right? Because it's filled in. And I'm going to use the letter L. So I'm going to print letter, and normal is dominant, so I'm going to use a capital L. So here, let's identify the individuals that are the easiest to identify, that we know without a doubt. And those are the individuals that are filled in, which means that they have the recessive phenotype. So by default, the only genotype they can have is homozygous recessive. So let's go back and fill out the individuals that we know for sure. So I think it's easier to start with this individual number 4, right? And the only way that they can have children that have two little letters is for individual 4 to be able to give a recessive allele. But we know that it's dominant because it's not filled in, right? So he is heterozygous. And so if we do the Punnett square for this, or we just look and see, all of these other two children, child number 8, 13, and 10, all have to be heterozygous. And they all have to be heterozygous because their mom can't give a capital letter. Okay? So, so now we're here. We can now look down here at this individual here. So this individual is homozygous recessive, and because it is homozygous recessive, we know that each parent has to be able to give them a lowercase l, a recessive allele. So that's why we know that his dad has to be heterozygous. Okay? For individual number 1, we don't know for sure, but we can assume that individual 1 is most likely homozygous dominant. And the reason why we can say that is because none of their children have the recessive trait, even though they have a father who has the recessive phenotype. So we're going to assume that this individual number 1 is homozygous dominant, and by default we can safely say that all of their children are heterozygous. So next we come to individuals 14 and 15, and we don't know. If we do the Punnett square of their parents, we can see that their parents can have we can see that their parents can have dominant children that can be either homozygous dominant or heterozygous, and we don't know for sure, so we're going to write them both in here. So for the next page, we'll go over it together, but I want you to try doing it yourself first and then watch the second video to check your answers.